All right, doors are closed. I think we can start. Hi, everyone. Thank you for attending my presentation. I will be talking about building scalable live streaming service based on AWS solutions. So first, I'll walk you through the AWS services, what they offer, what was like an example approach, and after that, I'll go to how we can integrate this infrastructure built on AWS with our application. A few words about myself first, maybe. Well, I actually graduated from robotics, but very quick I switched to Java programming, and right now I'm a senior Java developer in Devexperts. And the project, the talk will be based on a real project that we did in Devexperts. It's been developed for about 2 years now, and recently, like 2-3 months ago, it's been deployed to production. We've got about 1,000 users right now. It's of course a control release. So yeah, I'll be talking about a real project and the experience that we got building it, and hopefully that will be interesting for you guys. Throughout this project, we've been working very close with AWS, and for us it's also been a journey. I myself became a big enthusiast of cloud solutions and AWS. So let's get into it. First, I would like to talk about briefly how did we approach the problem, the challenge that was to build an application that would have live streaming. So we started with outlining some key features, the functionalities that the service would have to provide. So of course, live streaming, but we knew that we will have to have sort of on-demand streaming. So not just one pipeline, but possibly 50, possibly less, and we would have to be able to create more pipelines for live stream and manage the amount based on the demand of the application. Also, we have to save the live stream to a file, clip videos during the stream, and then allow the users to view all of this on the video on demand. And also, because the application has some other features, it was very important for us to keep low latency on the live stream. So the application is reactive, and everything's happening sort of real time. So what is media services? Well, it's actually a group of many services. There is a lot of them, and this is just a few examples. The ones that I will be focusing on this talk is Media Life and Media Package. They allow to ingest the stream and deliver it to the end users. But just to name a few more, there's Media Store, that is an optimized store for streaming videos. There's Media Tailor, which allows you to insert ads and monetize on the video streams. Media Kinesis, for example, allows you to deliver the stream to some kind of machine learning, for example, service. And Media Convert allows you to convert the videos to different encodings and cut and join streams. So there is a lot here, and I will be showing the example that we built in our project, but I think it's good to know that there's so much more to it, and you can really build what your application might need. So our approach was to use the Media Life and Media Package. I will dive into this a bit more, but the basic flow is more or less like this. So we have a source video, we've got a real stage with cameras and stuff like this. We process this, deliver to the end users through media package, and save it to S3 bucket. And again, using media package service, we are able to deliver the streams as video on demand. So let's start with the first pipeline, which is the live stream. We use Media Live, and it allows you to ingest live streams in different formats, HLS, RTP, RTMP. It also allows you to ingest like ready video files, MP4s, you name it. And then this is transferred to connected to Media Live channel, which is a repackaging service, which means that it allows to normalize the video. You can set different resolutions, different video qualities, and prepare the stream to be later delivered to the next service. It allows you to use HLS and Dash packaging. Dash is common to like delivery of high quality videos. HLS is a bitrate adjustable type of packaging, which allows you to deliver smooth video for the end user, no matter what like connection it is. So it's able to adjust resolution that it's sending to the end user. So the so it's just smooth for the end user, yeah. And then we push this to the media package, which allows us to create different endpoints. So we can actually adjust, we can say like for desktop applications, we want to have the highest quality 4K. For mobile devices, we might set a different endpoint and then deliver lower quality, but it's better for the user because he can have a smooth experience. It also allows us to set different options like replays, like up to 14 days on the live stream, and there are also some security settings, which I want to just briefly mention because security is very important. So media package allows you to set two different security types. First one is content delivery network, which is a rolling authorization key. So the client has to authorize himself with this key in a header. And that way we know that only authorized clients are able to get our video. The second type is a DRM, digital management rights. That is a more complex security. It's more complex to set up because you need a key management provider, but it allows you to encrypt the content delivered. So any kind of man in the middle tries to capture a video is handled there. That's secure. But yeah, for us, we decided CDN because it was a lot easier to set up, and I think like the basic security is covered by that. So just now I can tell you about latency. We did some tests actually on AWS, and first of all, I want to just tell you just a bit how can we measure the latency and where does it come from? So we need a start point, of course. So it can be what the software that sends the video to the AWS is sending at the time. And then what is available under the URL. So this can be measured by the time codes that are provided in the, attached to the video packages. And another experience is for the user, which also has a delay because he has to download the packages to his browser or smartphone. So what we've seen is that using our TMP streaming, it provides about additional 5 seconds to the delay. The processing in AWS is very fast. The documentation says it's real-time packaging, but we observe about 1 second, maybe less. And then the user has to download the packages. So this creates additional time. If you use HLS in the output, it's dependent on the HLS packaging. So if you make these packages as small as possible, you reduce the latency. So at the end, the latency that we achieved with our TMP input on the URL is about 6-7 seconds. For the user, there's additional time for downloading the last package, so it grows a bit, like 9 seconds of what the user sees. And this is really fast. If the source sends HLS files, it gets even faster. But this requires an on-site converter, usually, that converts the video from the camera to an HLS packaging. So the latency with the media service is actually pretty low. All right, and now we can move on to the second pipeline, which is video on demand. So how do we achieve that? The media package allows you to create harvesting jobs. So you basically send 2 time codes to the service, and it harvests the time codes that are under the public URL that allows you to view the video. So the latency that we spoke before, the T1, that's the time delay that you will see if you send those time codes. So for us, where we have an application where we send these timestamps during the live stream, we have to add this time of 5 seconds if it's RTMP. So that what we see is what we cut as the end result. And yeah, this harvest job, it's an asynchronous job. So it saves the packages to the S3 bucket, and then it creates a CloudWatch event that says, okay, the job was done, or maybe there was a failure. And then we can handle this by creating media package VOD asset, which then creates the URL. Just to show another example that actually allows us to achieve the same result, but I wanted to show this to give you an idea that, to build the same feature, it's not just one possibility. There's so many services in AWS that often you can choose the services that suits best for you. So it's possible to save directly to S3 from Media Live. And instead of using media package, you can use CloudFront CDN, which is a content delivery network, which then serves the stream to the users. And you can use media convert to cut the streams and again create a public URL in CloudFront. But we chose the media package. It's because it doesn't do any additional conversion. It's pretty fast, and it allows us to create those streams, save those streams during the live stream. And so we can allow the user to view those video clips already, like during the live stream we created. It takes 30, 40 seconds to save a few minutes clip, and the user can already view it. Also, what is very good in this, there's no additional configuration for the quality settings, additional resolutions, because everything that is under the public URL that the harvesting job takes is saved. All the HLS packages are saved in the same quality and resolutions. So then the delivery of the VOD is the same experience as the live stream. But as you notice, now I was just talking about one pipeline for one stream. And we said at the start that we want to be able to build from our application on demand more streams. So we want to integrate this with our application, with our backend, and build it into our system. So what do we need to achieve that? First of all, we're going to need AWS SDK, which allows us to control and manage the media services. We're going to have to build with this SDK all the actions like create, live stream, pipeline, delete, everything, start, stop. This is actually changing the media live state. And to handle the creation of video clips. And what's most important, we have to handle the asynchronous events from CloudWatch. So every time that we create a part of the infrastructure, we have to handle this information. We have to handle errors. So that's actually very important. Anything that happens in the AWS infrastructure, sometimes it might fail, and this error handling can be done by handling the CloudWatch events that actually let you know that, I don't know, this video harvesting clip failed, so you can then handle it and display it to the user. We are also going to need to persist some data, mainly the IDs of the infrastructure that we create, so we can, when we send another comments, we can have this handle of the infrastructure. And well, I'll be like using the native AWS solutions, but of course you could always use something else. But I think it's good for a start because this infrastructure is fully AWS managed, and it allows very quick and easy setup. So for the data persistence, we can use AWS DynamoDB, which is a NoSQL database. And for those, I don't know how familiar you are, how many of you use DynamoDB? Wow, okay, so I have an example here to make it a little more familiar for you. It actually has key, and it's a key value type, but the key is made out of two values, primary key and sorting key. So the primary key holds it's like a reference to an address in a physical server, so a partition. So everything saved under one primary key is in one partition, and that makes it very constant time to select the data from DynamoDB. And the pair, PK and sorting key, SK, has to be unique in the one table. So, for example, we can create from our application, we can make an ID for the one pipeline of the stream, and then save all infrastructure IDs as sorting keys. And this allows us to reach out to the database every time we need any ID of the infrastructure that we created. On the other hand, when we handle asynchronous events and we have just the ID of the infrastructure, we can use an inverted key, which inverts the SK and PK. So we can reach out to Dynamo by the SK value as well. So this allows us to persist this information that we need to handle each stream that we create. Now, we need to use the AWS SDK, and for us, we went for AWS Lambda, but of course, someone might ask, why not use microservice deployed in a Kubernetes? Well, you can, absolutely, but at least in our application so far, if you have just a few streams or 50, 100, it's still going to be not many requests, so your server will probably not do much. So it might be an easier solution to go with Lambda. You pay just for the time you run it. It's fully managed AWS service. And also a very good thing useful here is that you can invoke the AWS Lambda directly from CloudWatch event. So we can handle the asynchronous events from the infrastructure. A good way to start is to use Boto3 because it has very extensive documentation regarding media services. It's also another advantage of using DynamoDB is because AWS SDK already has the client. And the deployment of this Python script is very simple because the Boto3 library is already included in the Lambda environment, so you don't have to install any dependencies. You just upload the zip file, and you have ready-to-use functions. But we are on a Java conference, and you might be thinking, what is this guy talking about? We are Java enthusiasts. Well, the main issue is poor documentation in Java regarding media services. It's basically just Java docs. And the first thing you Google about Lambda with Java is that it has a cold start, which means that every function has to start the JVM environment, etc. But that's not entirely true, because you can actually use GraalVM. And GraalVM allows you to have a very quick startup. And then Java is actually a very high-performance language, so the execution of the code is faster. And all in all, it's actually a cost-saving solution. It also has the advantage that if you have a backend written in Java, you can share the API classes, and it really simplifies refactoring of your code. If it's in Python, you have to handle it in two places always. The poor documentation is still there, so what I would recommend for a quick start, build your POC in Python and then migrate to this Java code for Lambda. Because once you already have this simple examples that you work a little bit with, you can understand what configuration you have to provide, and then it's much easier to approach implementation of this API for media services. And then we need something that joins the communication between Lambda and our backend. So for us, it was to use a message broker, and AWS comes with SQS, which is, again, AWS managed service. It allows you to use high throughput queues, which are comparable to Kafka. It can handle like millions requests per second. Or FIFO messages, which are a bit slower. It also comes with a very easy setup of a pattern with using the dead letter quiz. So if there's any message that cannot be processed in the right way, you can redirect it to a dead letter and then handle it with an error handling solution that you might work with. It's also compatible with JMS interface, so if you ever worked with any other messaging, you might be already familiar with that. So it's a pretty simple setup. And all of those services that are AWS managed, they come with monitoring tools, and they usually, by default, they already have the setup for that. So all the Lambda functions, they have logs in CloudWatch. You can see a lot of metrics regarding the streaming, like how much data you stream, how many incoming requests for the public URLs you are having. Also the sorry, I got started. Yeah, so you also can see how much traffic you get on the live streaming, and that's very cool information for the client as well. So let's see what the final solution would look like. We have some administrator user that sends requests through REST API to our application saying, okay, I want to create a stream, I want to start, stop it, and then delete the AWS infrastructure that we created. So all of these comments are then sent to SQS, and Lambda function is invoked, and then it sends through AWS SDK, sends comments to AWS to create the infrastructure that is needed. And then there's usually some asynchronous processing happening in the AWS Media Services. So we save the information in Dynamo of the IDs, and when there is a CloudWatch event, we can look up into the Dynamo, locate which live stream it is, and then send back the information to our main application, what has happened in AWS, and we can provide the user with the streaming and all the notifications that might happen during the stream. What I'd like to add is that, well, as you can see, I spoke mostly about like architectural approach. So I don't want to dive deeper into like code implementation, because you can find this in the documentation, and it would also take hours. But if you would like to discuss more about it, you can find me at the Devexperts stands, or you can send message to me on LinkedIn. I want to invite you to do that. And also you can follow Devexperts. We do interesting projects with trading. And yeah, that would be it from my side. Thank you. If there's some questions, feel free to ask now or after.